Welcome to Mbose Educator. Mathematics Class 10, New Book, Chapter 1, Real Numbers, Exercise 1.2, Question number 1, 2, and 3. This is exercise 1.2. In this exercise, altogether 3 problems are there to solve. In this video today we shall solve question number 1, 2 and 3. That means all the problems. Let us take first question number 1. This is question number 1. The question is prove that under root 5 is irrational. To prove under root 5 as irrational, we have to assume that under root 5 is rational first. Alright. So we shall write, let us assume that under root 5 is a rational number. Rational. When it is rational number, then therefore under root 5 is equal a by b. That means when a number is in the form of a by b, then it is a rational number. And one more condition should be there, that a and b must be co-prime. That means a and b co-primes. When a and b co-primes, then a by b is a rational number. Alright, it's very important. Remember this point, a and b are co-primes. Co-prime means they don't have any other factors other than 1. Their common factors is only 1. Then it will be prime number. It will be rational number. When other than 1 they will have some factors, then a by b will not a rational number. Remember this point. Now we can do one thing, squaring both sides. Squaring both sides means under root 5 also be squared and a by b also be squared. So we have written squaring both sides. What we shall get, this square cancels root over, then here will be 5 is equal, here will be a square by b square. Next we have to do cross multiplication to make it simple. A and 1, a square and 1, then it will be a square only, and b square and 5. This is called cross multiplication. B square and 5 will be 5b square. Here we got one thing, that a square equal 5b square. It means a square is a multiple of 5. Means 5 is a factor of a square. We can write any one of this point. So we shall write here in the right hand side, a square is multiple of 5, because a square equal 5b square. It means a square is a multiple of 5, and 5 is a factor of a square, because factors and multiples are the reverse term. When a square is multiple of 5, then a is also multiple of 5. So these 2 points we should write. Next, so here we should do one thing. This we can write as an equation. When we got a is also a multiple of 5, we can do one thing. We can let one more thing. Let a is equal 5c, because a is the multiple of 5. So we can write a equal 5c, and c is any integer. C is any integer. Again squaring both sides. Squaring both sides we get a square is equal 5c square. A square will be similar, a square is equal, when we shall remove the bracket, 5 will be squared, then it will be 25 and c square. Here we can do that from equation 1. We can write from equation 1. From equation 1, a square equal 5b square. So in the place of a square, we can write 5b square. Because 5b square means a square, and a square means we can write 5b square. In the place of a square, we shall write 5b square from equation 1. Next, right hand side already what is there? 25c square. Both side 5 is common, so we can divide. We can divide both side by 5. We can divide both side by 5. When 5b square is divided by 5, answer will be b square equal 25 will be divided by 5, then answer will be 5 and c square will be as it is. So b square equal 5c square. It means b square is the multiple of 5. We can write it like earlier. From this condition we can write b square is multiple of 5. When b square is multiple of 5, then b is also multiple of 5. Here did you notice one thing, that we find here a is also, see here, a is also multiple of 5. Again here we got b is also multiple of 5. From these two statements we can find, or we can write, both a and b are the multiples of 5. This means a and b are not co-prime. When we got that a and b are not co-prime, then we can say under root 5 is not a rational number. All right. Hence, our assumption, what we assume, our assumption is wrong. Therefore, we can conclude that under root 5 is an irrational number. All right. So we have solved here question number 1. Let us solve question number 2. This is question number 2. The question is, prove that 3 plus 2 under root 5 is irrational. Let us solve it. First of all, we shall consider, or we shall assume, this number is a rational number. So we shall assume, let us assume that let us assume that 3 plus 2 under root 5 is rational. When this number is rational, then this number we can express as a by b form. That means 3 plus 2 root 5 is equal A divided by B. This is the condition of rational number, and another condition is that A and B must be co-prime. Co-prime, all right. Now we shall calculate this. This 3 we shall transfer to the right hand side. It was plus, it will convert it to minus. So 2 plus under root 5 will be left hand side is equal right hand side. A by B will be as it is, and this 3 will go to the right hand side. It will be minus 3. Sorry, here we have made one mistake. This is not plus, this is actually into. All right, this number 2 into under root 5, and this 3 was plus, it will go to the right hand side and it will be converted to minus. Now 2 under root 5 will be as it is equal. Here we have to take LCM, as there is a fraction and between minus symbol is there. B and 1's LCM will be B. By B we have to divide B. Answer will be 1. 1 into A will be A itself minus. By 1 we have to divide B. Answer will be B. B into 3 will be 3B. Now this 2 is multiplied with under root 5. So 2 now we shall transfer to the right hand side. In the left hand side only 5 will be left, equal A minus 3B. This 2 was in the left hand side, the 2 was multiply. It will go to the right hand side, it will be divide. So it will be sit in down. Alright, and B is as it is. Now this number we can see, this number is in the form of A by B. That's why it is a rational number. We can write here A and B are integers. When A and B will be integers, then this will be a fraction. Then we can write here A and B are integers, then A minus 3B divided by 2B is a rational number. Alright, when A and B are integer, then this number will be a rational number. Now we can write if this number, that means A minus 3B divided by 2B is rational number, is rational, then this number is rational, then 5 under root 5 is also rational, because this is equal. When under root 5 is equal this number and this number is rational, means this number also rational. So you can write if A minus 3B divided by 2B is rational, then under root 5 is also rational. But here there is a problem. We know under root 5 is not a rational. We have to write but under root 5 is not a rational. Here our assumption is wrong. Our assumption is wrong. So when we got that our assumption is wrong, that this number was rational number, now we can write therefore 3 plus 2 under root 5 is irrational. If it is not rational, then it is irrational. Hence proved. Hence proved. We have proved this. Alright. So here we have solved question number 2. Now let us solve question number 3. This is question number 3. The question is prove that the following are irrationals. In this question there are 3 parts, number 1, 2 and 3. We have to prove all these numbers are irrational. First of all, let us solve part number 1. The number is 1 divided by under root 2. We have to prove this is an irrational number. So like earlier, we shall assume this is a rational number. Let us assume that one under root 2 is a rational number. When this is a rational number, therefore 1 by under root 2, when it is rational number, we can express it in the form of a by b. And remember, a and b are co-prime. Alright, now we can do one thing. We have to do cross multiply for make it simple. A into under root 2 or b into 1, any one we can do. B into 1 means it b only is equal under root 2 into a, that means under root 2a. Now a we shall bring to the left hand side, it was multiply, it will be divide, b by a is equal under root 2 will be as it is. Now you can see b by a is in the form of a by b, that means this number is a rational number. So you can write here, since b by a is in the form of a by b, this means b by a is rational. So b by a is rational because b by a is in the form of a by b. When b by a is rational, then b by a is equal also rational, that is under root 2. b by a is equal to under root 2. So when b by a is rational, then under root 2 is also rational. This is also we can write here, if b by a is rational, if b by a is rational, then under root 2 also rational. But this fact is not correct because under root 2 is irrational. But under root 2 is irrational. Here our assumption is wrong. Here our assumption is wrong. Therefore 1 by under root 2 is irrational. We can write this. This is the fact. This number is irrational. Hence, proved. We have proved this. Alright. So here we have solved part number 1 from question number 3. Now we shall solve part number 2 from question number 3. This is part number 2. Here also we have to prove this number is irrational. So let us assume that 7 under root 5 is rational. When this number is rational, then it has a form a by b. Therefore 7 under root 5 is equal a divided by b. And there is a condition we have to write that a and b co-primes. Alright, now let us solve this. This 7 is in relation with 5 is multiply. We have to take it to the right hand side, it will be divide. Right. So under root 5 will be the left hand side, equal right hand side a by b, and this 7 will go to the right hand side, it will be sit in down because it will be divide. Alright. When it is divide, that means we can write in down. Now you can see a by 7b is in the form of a by b. We can write a by 7b is in the form of a by b. This means a by 7b is a rational number because this is in the form of a by b. This means a by 7b is a rational number. When a by 7b is rational number, then it is equal to under root 5. It is also a rational number. If we can write, if a by 7b is rational, then this a by b is rational, then under root 5 is also rational. But under root 5 is irrational. Alright, when under root 5 is irrational, then our assumption is wrong. So here our assumption is wrong, that this number, what was the number, you can see 7 under root 5 is a rational number, or that assumption is wrong. That's why you can write now, therefore 7 under root 5 is irrational. When this is not rational, then it will be irrational. Alright. We have to write, hence, this is hence proved. Alright. So here we have solved part number 2. Now we shall solve the last part, part number 3. This is the last part, part number 3 of question number 3. We have to prove this 6 plus under root 2 is irrational. Before proving this is irrational, we have to assume this is irrational. So we shall write, let us assume that 6 plus under root 2 is rational. If it is rational, then it has a definite form. 6 plus, therefore 6 plus under root 2 is equal a by b in this form. That means a and b co-prime. Alright. Now we can do one thing. Under root 2 will be in the left hand side is equal a by b as it is in the right hand side, and this 6 will go to the right hand side. It was plus, it will convert to minus 6. Under root 2 is equal, here we have to take LCM of the denominators b, and once LCM will be b divided by b, answer will be 1 into a will be a only, minus 1 is b is divided by 1, then it will be b and 6 multiplied, it will be product will be 6b. Alright, here we can do one thing. A and b are integers. We can write a and b are integers. When a and b are integers, when a and b are integer, then a minus 6b divided by b is in the form of a by b. This means a minus 6b divided by b is rational. A minus 6b divided by b is rational. When a minus 6b divided by b is rational, then it is equal to under root 2 is also rational. Alright, we can write, if a minus 6b divided by b is rational, then under root 2 is also rational, but under root 2 is irrational. We know that under root 2 is irrational. Here our assumption is wrong. Here our assumption is wrong. So here we can write, here 6 plus under root 2 is irrational. Hence proved. We have proved this. This is irrational number. So here we have solved all the problems of exercise 1.2. Let us meet again in the next video. To get all the classes regularly, please subscribe my channel. We shall meet again in the next video. Till then, thank you very much.